Hi, hello dear students. In this video, we are going to see NEET exam question on magnetic property of complex compounds. Suppose if you take this one question which is asked in 2021, they are given as one tabular column. Means two columns they are given, list 1, list 2. There are two lists they have provided to us, and they are asking us to correctly choose the list. That means correct answer for that list they asked. That means in this list 1 they are given A, B, C, D. List 2 they are given Roman number 1, 2, 3, 4 and all. So we have to find out the correct list after finding the mu value of these complex compounds. First of all, we have to notice all these complexes are actually belonging to iron. That means you need to practice iron's electronic configuration, outer electronic configuration. Iron's Z value is 26. Its outer electronic configuration is 3d6 4s2. Okay. Do remember that Fe, when it is associated with the neutral ligands, its oxidation state is equal to charge given on the coordination entity. That means in our B and D options on the list, we have Fe is present in +2 state, Fe is present in +3 state. So here +2 and +3 states are actually the same. +2 and +3 states are also there for iron. In the C option also we have the same thing. That means in C and D options we have iron in +2 state. In A and B options we have iron in the +3 state. A and B options iron in the +3 state. In the list 1, iron oxidation states were identified. The same time, whenever iron is present in +2 state, its electronic configuration is 3d6. Do remember 4s is 0, even 4p is also 0. If necessary, we will take 4d also for weak field ligand cases. And iron in +3 states, its oxidation state is d5, 4s is 0, 4p is 0, 4d is also 0. Now talking about the weak fields and strong field. What is weak field? And iron Cn minus is strong field. So Cn minus and H2O. Whenever we observe two types of ligands in this list, Cn minus is trying to change that means rearrange the d orbitals if needed. That means it gives inner orbital complex, and H2O gives outer orbital complex. Do remember, means inner orbital complexes usually don't give the maximum paramagnetic, maximum mu value. Mu value means these are the Bohr magnetons values, magnetic moment values. In the list 2 we have. That means if you consider Cn minus and H2O related examples all will have higher mu values will be there. So like that if you observe in this, H2O is there with iron. H2O with iron, highest oxidation state is +3 here, and definitely that H2O in the highest oxidation state, in the +3 oxidation state, is said to be exhibiting highest mu value. So this B is said to be exhibiting highest mu value. So that means Fe H2O 6 times 3 plus, we have D5 configuration is there. It will utilize sp3 D2 hybridization and inner d orbitals will have 5 unpaired electrons. So when there are 5 unpaired electrons are there, definitely mu value will be root of 5 into 5 plus 2. We have square root of n into n plus 2 Bohr-Magnetons formula. It will give root 35. It will be 5.92 Bohr-Magnetons. So B is 2. So B value is 5.92. B value. In the same way, if you take FeH2O 6 times 2 plus for D option, for D, so that is FeH2O 6 times 2 plus for D in the list 1. If you see, it is also outer orbital complex. We have D6 configuration is there. The configuration is D6. Here configuration is D5. So D6 is not get disturbed. So that's why what will happens in this category, you will take the help of sp3d2 hybridization, again outer orbital complex. We have unpaired electron number is 4 in D6 configuration. Okay, that can be easily visualized if necessary, like this 1, 2, 3, 4, 5, 6. So there are 4 unpaired electrons are there. So n is equals to 4 means what is the mu value for this one? 4 unpaired electrons mu value. Mu is equals to square root of 4 into 4 plus 2 means 6 4 is 24. That means root 24 close to 5. So 4.90 is there. We have 4.90 is list 2 Bohr-Magnetons is the answer. So D3, B4. So that means B we have it is 4 and D we have that is 3. Okay. Coming to the rest of the other two things, if you take C means that is FeCN 6 times 4 plus FeCN 6 times 4 plus, sorry 4 minus. So in this, Cn is allowing inner orbital complexes. So octahedral complex it is, rearrangement takes place. In the Fe2 plus we have D6 configuration. So that D6 configuration is going to get rearranged. So after that what will happens, we have to utilize the 2 d orbitals from inner orbital and 1 s orbital from 4s and 3 p orbitals from 4p. If you take, you will get the hybridization d to sp3 hybridization. All the orbitals are completely paired up. So in such a case, what will happens means there is no unpaired electron will be noticed in this case. So no unpaired electron in this case noticed means we can definitely understand that mu value for this one is going to be 0. So mu value for this one is going to be 0. 0 Bohr-Magnetons for FeCN 4 times. So C, whatever is the C for this mu value is 0, that is 2. So rest of the other one definitely is nothing but the 1.73. That also we will check it off here. That is A, that is FeCN 6 times 3 minus. So FeCN 6 times 3 minus is Fe is 3 plus. D5 configuration is there. If D5 configuration undergoes a kind of rearrangement, 5 electrons will be used, will be rearranged in 3 orbitals and 1 will remains unpaired, and hybridization remains the same like that of FeCN 6 times 4 minus. Okay. So in such a case what will happen, this one unpaired electron gives little magnetic moment value of square root of 1 into 1 plus 2 Bohr-Magnetons means it is root 3, that is equals to 1.73 Bohr-Magnetons for A formula. So A4, so it is A4 and B we have 5.9 to B1, that is therefore B1. So this is the correct list which is matching, that is B is 1, B1 and D3, B1, D3, C2, A4, A4, A will be 4. This is the correct list of the matching the magnetic moment values of the given iron complexes asked in 2021. Okay, thank you.